Hi, Assalamualaikum and good morning. I am Nurul Alia Pasha binti Muhammad Zamri from SJI1. Today, I will present a brief overview of the main type of organic reaction. These reactions are essential in transforming carbon-based compound and form the foundation of organic synthesis and industrial chemistry. First, substitution reaction involve replacing one atom or group with another. Nucleophilic substitution include the SN1 and SN2 mechanism. Second, addition reaction occur mainly in alkane and alkenes. Two reactions combine to form one product. Common examples include electrophilic addition, nucleophilic addition, and hydrogenation, where hydrogen is added to a double bond in the presence of a metal catalyst. Third, elimination reaction involves removing atoms or groups to form a double bond. E1 occurs in two steps, whereas E2 happens in one concerted step and requires a strong base. Next is oxidation and reduction. Oxidation and reduction reaction play a major role in converting alcohol to aldehyde, ketones, or acid in reducing alkanes and alkenes. Next is condensation reaction. Condensation reaction involves two molecules joining while eliminating a small molecule such as water, as seen in esterification. Lastly, rearrangement reaction involves internal shift of atoms within a molecule without adding or removing atoms. In summary, the primary categories of organic reaction include substitution, addition, elimination, oxidation, reduction, condensation, and rearrangement. Each pathway follows characteristic mechanism and remains essential in understanding organic chemistry. That's all from me. Thank you.
Good morning everyone. Today I will be talking about alkenes, a group of organic compounds that are very important in chemistry industry. What are alkenes? Alkenes are unsaturated hydrocarbons. This means they contain at least one carbon double bond, which makes them more reactive than alkynes. The general formula for alkenes is CnH2n. The simple alkene is ethene, also known as ethylene. For IUPAC system, alkenes are named using the IUPAC system. We choose the longest carbon change with the double bond, change the suffix to "-ing", and number the chain to give the double bond the lowest possible number. For example, 2-butene has 4 carbon atoms and the double bond starts at carbon number 2. Okay, alkenes undergo this for basic preparation methods of alkenes. We have 4: dehydration of alcohol, dehydrohalogenation of alkene halides, partial hydrogenation of alkenes, and cracking of hydrocarbon. For reaction of alkenes, alkenes undergo electrophilic addition reactions such as adding HBr or Br2. They also follow Markovnikov rule, where the hydrogen adds to the carbon with more hydrogen atoms. This anti-Markovnikov addition product parasite effect. And then we have halogenation of alkenes polyethylene and polypropylene. They are also used in synthetic rubber, detergent, solvents, and even biofuels. In conclusion, alkenes are not just important in urban chemistry. They are essential in many products we use every day. And then, yeah, thank you for listening my presentation.
So hello, my name is Nismawati. I want to talk about alkynes. So what is alkynes? Alkynes is unsaturated hydrocarbon containing at least one carbon-carbon triple bond. The general formula CnH2n-2. The end of name of alkynes we put Y and E. IUPAC nomenclature. First, identify the longest carbon chain, and then the number the carbon chain, and then number the parent chain, and last add substitute and position number. For example of alkynes is simple alkyne. When have 2 carbon we call it ethyne, and 3 carbon we call it propyne. For complex alkyne, for this picture we have a 4 carbon chain, so we call it 1 butyne, and at the carbon 3 have a methyl, and we call 3 methyl 1 butyne. For preparation of alkyne, we use elimination reaction. For double dehydrohalogenation, this two-step elimination process use strong base like NaNH2 to remove HX twice from dehalogenated compound. For the reaction process via an alkene intermediate and required harsh condition. That means high temperature and strong base. For important reaction of alkyne, first hydrogenation of alkyne by complete hydrogenation. Use exists H2 with PT, PD or Ni as a catalyst, and we will get the alkane. And when partially hydrogenation, when we use the leader catalyst, we get a cis alkene. When we use NaNH3 as a catalyst, we will get trans alkene. So next, halogenation of alkene by addition of halogen. First, we will alkyne react with halogen to form tetrahalide or dihalide. Secondly, alkyne react with halogen again to get a trans dihalide as the initial product. So application of alkyne by alkyne in pharmaceutical synthesis is by application building block for complex drug molecule, linkage in bioconjugation chemistry. Notable example, efavirenz in HIV treatment and tazarotine in psoriasis medication. Okay, only that I want to say about alkyne. Thank you.
Hi, my name is Nur Aida Shafika, and I'm going to present about stereochemistry. First of all, let's see the difference between constitutional isomer and stereoisomer. Constitutional isomer is a specific type of isomer that share the same molecular formula but have different bonding. For example, 2-methylpentane and 3-methylpentane both have the same molecular formula but with different connectivity. Next is stereoisomer. Stereoisomer is isomer that differ in spatial arrangement of atom rather than order of atomic connectivity. Next is chirality. A molecule is chiral when it is a non-superimposable molecule and that its mirror image is not the same as itself. Just like our hand, the mirror image is similar, but it is not identical when we try to overlap. For an enantiomer, it is a pair of a molecule that exists in two forms that are mirror image of one another but cannot be superimposed one upon the other. For example, in fragrance perception, carbon enantiomer have different smell. Like S-carbon give the smell of spearmint, while the R-carbon give the smell of a caraway seed. Next is optical activity. Optical activity is the physical property of chiral compound that rotate plane polarized light measured using a polarimeter. If it gives positive dextrorotary, it will rotate clockwise. while negative laboratory will rotate counterclockwise. It is commonly in sugar industry to measure the sugar concentration and pharmaceuticals to ensure drug purity and efficacy. The stereomer is a stereomer of a substance that are not mirror image of each other, and it has different properties and different specific rotation. So compound is a molecule with a multiple stereocenter that is superimposable on its mirror image, and it is optically inactive. For the last part is racemic mixture. It is a mixture with equal amount of left and right-handed enantiomer of a current molecule, which resulting in zero optical activity as the rotation cancel each other out. That's all from my part.